Hello, good morning students. Welcome to the online class. In the previous videos, we already discussed about the detailed study of 17th group elements. In that 17th group elements, physical properties, chemical properties, and the detailed study of HCl as well as chlorine. In this video, I am going to take another important concept, that is related to 18 group elements. 18 group elements. Students, helium, neon, argon, krypton, xenon and radon. These are the elements present in 18 group elements. Okay, students, remember, these 18 group elements are chemically inert. Yes, these 18 group elements are chemically inert and they form only less number of compounds. Yes, students, remember, due to the stable electronic configuration and due to the high ionization energy, 18 group elements are chemically inert. Students, another one very important concept, that is these 18 group elements are also called as rare gases because its availability is only up to 1%. Why these 18 group elements are called as rare gas elements or rare gases? Because their availability is only up to 1%. And these 18 group elements are also called as noble gases. Why the 18 group elements are called as noble gases? Remember students, they are chemically inert and they form only less number of compounds. Therefore, these are called as noble gases. And another point to remember students, among these 6 noble gases, radon, it is one of the radioactive noble gas. Radioactive noble gas. Next, argon. It is abundant in earth crust. It is abundant in earth crust. And another one, it is helium. It is most abundant in the universe. It is most abundant in the universe. Yes, remember students, it is very important. Radon, it is one of the radioactive noble gas, and argon is most abundant in earth crust, and helium, it is more abundant in universe. Yes, students, next, the general electronic configuration. General electronic configuration of 18 group elements is Ns2 Np6. As remember, Ns2 Np6. 18 group elements or 0 group elements. General electronic configuration is Ns2 Np6. You see here students, I take the elements in one column. Next, atomic number. Next, electronic configuration. As remember, especially in your annual examination, the 1 mark question is on 18 group elements. So observe carefully. Element here, helium, neon, argon, krypton, xenon and radon. Okay, its helium atomic number, is 2, neon is 10, next argon 18, krypton 36, xenon 24 and radon is 86. Okay, students, its electronic configuration is 1s2 helium. Next, 10. Next, neon, its electronic configuration is Next argon, here neon 3s2 3p6. Next argon 3d10 4s2 4p6. Next xenon, its electrical configuration is krypton 4d10 5s2 5p6. Next radon, its electron configuration is xenon 4s14 5d10 6s2 6p6. Just remember the electronic configuration of respective elements which are present in 18th group elements. ನೆನಪಿಡಿ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇವಾಗ ನೀವು ಇನ್ನೊಂದು ಎಕ್ಸಾಮ್ ಕ್ವಶನ್ ಪೇಪರ್ ನೋಡ್ತಾ ಬಂದ್ರೆ ಅಲ್ಲಿ 18th ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಮೇಲೆ 1 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಕೇಳೋ ಚಾನ್ಸಸ್ ಬಹಳ ಅದ. ಹೌದಾ? ಅದಕ್ಕಾಗಿ ಸ್ವಲ್ಪ ಇದ್ರೆ 1 ಮಾರ್ಕ್ಸ್ ಯಾವುದು ಕೇಳಬಹುದು. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಸರಿಯಾಗಿ ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿ ಅದರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳಿ. Okay, students, this is about the general electronic configuration is ns2 basis and particular electronic configuration are written on the board. Okay, helium 1s2, neon 2s2 2p6 and neon 3s2 3p6 is the argon, and krypton electronic configuration is argon 3d10 4s2 4p6. Okay, next the point of general properties. General properties. Okay, students, what are some general properties? In that first one, I take atomic size. Atomic size. What happens to the atomic size? If you move down the group in presence of 18 group elements, in after the atomic size, students remember atomic size of 18 group elements. If we move down the group, it increases. Why atomic size increases down the group? We know, students, if we move down the group, the number of cells increases, means atomic number increases. ಇಲ್ಲಿ ನೋಡಿ, ಎರಡದು ಆಮೇಲೆ 10 15 36. ಹೌದಾ? ಹಾಗಾದ್ರೆ ಈಗ ನಾವು ಕೆಳಗಡೆ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ನೋಡ್ತಾ ಹೋದಂತೆ ಒಂದಕ್ಕಿಂತ ಒಂದು ಏನಾಗ್ತದೆ, ದೊಡ್ಡ ಸೈಜ್ ನಾಗ ಕಂಡು ಬರ್ತವೆ. Therefore atomic size increases. Atomic size increases down the group. Atomic size increases down the group. Next, second point, ionization energy of students. Remember, due to the stable ns2 np6 electronic configuration. Yes, remember students, due to the stable electronic configuration, 18 group elements have high ionization energy. Yes, remember, this is very important. Due to the stable ns2 np6 means it follows after 2. Is it right? Yes. In the valence cell there are 8 electrons. They are chemically inert. Due to the stable electronic configuration, the 18 group elements have high ionization energy. But if we move down the group with respect to 18 group elements, the ionization energy decreases. Ionization energy decreases. Usually ಏನಂತೆ ನಾವು 18 group elements ಇದ್ದು ಅಲ್ಲಿ ns2 np6 ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ನಾವು ಹೊಂದಿರೋದ್ರಿಂದ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ಅವು ಹೆಚ್ಚು ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿಯನ್ನು ಹೊಂದಿರ್ತಾವೆ. ಆದ್ರೆ ಅದೇ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ನೀವು ಕೆಳಗಡೆ ನೋಡ್ತಾ ಹೋದ್ರೆ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ ಏನಾಗ್ತದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗಿರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಒನ್ ಪಾಯಿಂಟ್, electron affinity. Yes, students, you know what is electron affinity? It is the amount of energy released when an extra electron is added to the outermost cell. Okay, what happens to the electron affinity? Remember, students, due to the same point, due to the stable electronic configuration, electron affinity of 18 group elements is also high. But if we move down the group, electron affinity is also decreased. Stable ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇರೋದ್ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅಫಿನಿಟಿ ಕೂಡ ಏನಾಗ್ತದೆ 18 ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದ್ದು ಹೈ ಅಂತ ಕಂಡು ಬರ್ತದೆ. ಬಟ್ ಅದೇ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ 18 ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ಕೆಳಗೆ ನೋಡ್ತಾ ಹೋದ್ರೆ ಅವುಗಳ ಎಲೆಕ್ಟ್ರಾನ್ ಅಫಿನಿಟಿ ಏನಾಗ್ತದೆ ಡಿಕ್ರೀಸ್ ಆಗಿ ಕಂಡು ಬರ್ತದೆ. ನೆಕ್ಸ್ಟ್ another one very important point students, that is fourth one, electronegativity. Electronegativity. Yes, what is electronegativity? It is a tendency of an atom to attract the shared pair of electrons. Is it right? Yes. Remember students, electronegativity of 18th group elements is 0. Why it is 0? Because they are chemically inert. They already had the octave configuration in the valence set. Electronegativity of 18th group elements is 0. Is it right? Yes, these are some general properties of 18th group elements. Next, go to the another concept. That is physical properties. Physical properties of 18th group elements. Some physical properties. What are some physical properties? In that first one, I write one point, students. Is the point? These are monoatomic. Yes, this means 18 group elements are monoatomic because the bond order is 0. Yes, we know they are chemically inert and 18 group elements are monoatomic. Next, another point. They are colorless, odorless, and tasteless. That's another point. And sorry, ಇವಾಗ 18 ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಕಲರ್ಲೆಸ್ ಆಗಿರುವಂತ ಓಡರ್ಲೆಸ್ ಇದಾವ ಮತ್ತು ಟೇಸ್ಟ್ಲೆಸ್ ಇದಾವ. ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಪಾಯಿಂಟ್, ದೇ ಆರ್ sparingly soluble in water. ಅವೇನಂತ ವಾಟರ್ ಒಳಗೆ ಸ್ವಲ್ಪ ಮಟ್ಟಿಗೆ ಏನಾಗ್ತಾವ ಅಂತ ಸ್ವಲ್ಪ ಮಟ್ಟಿಗೆ soluble are. Another point, they have low melting point and boiling point. ಯಾವ ಇದೆ ಅಂದ್ರೆ 18th group elements, so they have low melting point and boiling point. Why? Students, remember when you observe these 18th group elements, in that only a single type of interatomic interaction is present. Remember, in 18th group elements, interatomic interaction is present in presence of 18 group elements. Therefore, they have no melting point and boiling point. Interatomic interaction means usually it is dispersion force. Only one type of force is observed in the atoms of a 18 group elements. Therefore, they have no melting point and boiling point. Okay, students, these are some physical properties. Next, another concept, chemical properties. Chemical properties of 18 group elements. 18th group elements. Okay, students, in presence of chemical properties of 18th group elements, first we remember one point, that is they are chemically inert. Very important question for 1 mark question. 18 group elements are chemically inert due reason. Why they are chemically inert? Remember, students, answer for this question is they are chemically inert because the stable ಇರ್ತಕ್ಕಂಥ NH2 NP6 ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಕಂಡು ಬರೋದ್ರಿಂದ ಅವೇನಾಗ್ತಾವಂತ ಕೆಮಿಕಲಿ ಇನರ್ಟ್. ಇನ್ನೂ ಒಂದು ಪಾಯಿಂಟ್ ಬರೀಬಹುದು, ಬಿಕಾಸ್ ಆಫ್ ಹೈ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ. Because of high ionization energy. Students, you know what is ionization energy? It is the amount of energy required to remove the innermost electron of an isolated gaseous atom. In presence of noble gases, they contain stable electron configuration, means octet group. If you add at time an electron, it requires more amount of energy. Therefore, they are chemically inert. Okay, students. Next, another point is related to one very important compound, HCPTF6. Yes, students. Remember, this is also very important. One of the famous scientists is a British scientist in 1962, named Bartlett. One of the British scientist named Bartlett, he proposed one noble gas containing compound. Remember, this one is the first noble gas compound which is given by Neil Bartlett in 1962. Remember, noble gas ಪ್ರಥಮ ಕಂಪೌಂಡ್ ಅಂತ ಹೇಳ್ಬೋದು. ಯಾವುದು? HCPTF6. This means scientist Neil Bartlett, he proposed one noble gas containing compound. He passed xenon gas into, remember, usually Neil Bartlett, he passed xenon gas into the platinum hexafluoride. Yes. Write the reaction here. When xenon gas is passed through the PTF6 in platinum hexafluoride, then we get the complex, one of the complex, that is HCPTF6. Students, remember, when xenon gas is passed through the platinum hexafluoride, one of the complex, that is xenon hexafluoroplatinate is formed. What is the name of this complex? Xenon hexafluoroplatinate. Remember, this one is the first compound which contains the noble gas. It is given by the scientist Neil Bartlett. Usually, xenon gas is passed through the platinum hexafluoride. At the time, the complex xenon hexafluoroplatinate is formed. Okay, students. Next, another concept: xenon fluorine compounds. Next concept: xenon fluorine containing compounds. Students, in presence of xenon fluorine compounds, there are usually three types of compounds observed. One is XeF2, next XeF4, and XeF6. Yes, there are three types of xenon fluorine compounds. One is XeF2, XeF4, and XeF6. Students, when xenon is reacted with the fluorine in presence of different temperatures and different pressures, these compounds are formed. Usually, ನಿಮಗೆ xenon ಮತ್ತು fluorine ಇರ್ತಕ್ಕಂಥ compounds ಅಲ್ಲಿ usually ಮೂರು ತರ ಕಾಣ್ತಾವೆ. ಅವು XeF2, XeF4 and XeF6 ಅಂತ ಕಾಣ್ತಾವೆ. ಇವು ಪ್ರಿಪರೇಷನ್ ಅನ್ನು ನೋಡಿದಾಗ xenon fluorine ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿರ್ತದೆ, ಆದರೆ ಕಂಡೀಷನ್ಸ್ ಬೇರೆ ಬೇರೆ ಆಗಿರ್ತಾವೆ. ಅಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ಮತ್ತು ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ಪ್ರೆಷರ್ ಇನ್ವಾಲ್ವ್ ಆದಾಗ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ಕಂಪೌಂಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗೋ ಚಾನ್ಸ್ ಕಂಡುಬರ್ತದೆ. Let's see that first one. I take the preparation of XeF2. Here, when xenon is reacted with fluorine F2, under 673 Kelvin temperature and 1 bar pressure. Remember students, when xenon is reacted with fluorine at 673 Kelvin temperature and 1 bar pressure, we get the product HCl2. Is it right? Yes, remember. Next another type, HCl4. When the xenon is reacted with F2 under 873 Kelvin temperature and 7 bar pressure. Remember the conditions are very important here. When xenon is reacted with the F2, means fluorine molecule, and then under 873 Kelvin temperature and 7 bar pressure, you get the product HCl4. But here F4, therefore I make this 2. Yes. Next another one, HCl6. Is it right? Yes. When Hc is reacted with F2 and 573 Kelvin temperature and 60 to 70 bar pressure, we get the product HCl6. Is it right? At the time I write the value 3 for balancing the reaction. Okay students, when Hc is reacted with the 3 moles of fluorine molecule under 573 Kelvin temperature and 60 to 70 bar pressure, xenon hexafluoride is formed. Students, this HCl6 is also possible when HCl4 is treated with the O2 dioxide difluoride. During this time also we get the product HCl6, but the condition is this reaction takes place at 140 Kelvin temperature. HCl4 when it is reacted with O2F2, at that time also we get the product HCl6, but I think it is not balanced, therefore the product is observed here O2. Now it is balanced? Yes. HCl4, F2, F6 plus O2. Yes please. This is about the xenon fluorine compounds. Usually there are 3 types of compounds. One is HCl2, another one HCl4 and another one HCl6. When they form when xenon is reacted with fluorine under different type of pressures and different type of temperatures involved in a particular reaction. Students, this is about the chemical properties of ethyl group elements. In the next video, we will see another concept. Thank you.